All right, so here we go. Special logs and change of base theorem. So the logarithm with base 10 is called the common logarithm. By the way, I often make this a test question, and you have a big test coming up. Okay? So base 10, it's called common logarithm. It's denoted by log base 10 or just log. So if they don't put a base next to the log, we assume that it's base 10. It's called a common log because our number system is base 10, and so they're used more than any others in science and math. Okay? And there's even a button for it. So if you see log base 10, they use it so much that they decided this is the one we're going to do a shortcut for. We're going to leave the 10 off. Okay? So it says try these on your calculator. This is where you're going to use the actual log button, which is right here on the side, LOG log. Okay, so you're going to hit the log key and put in 142, and we'll just round it off. So it comes out approximately 2.15. Okay, if we do log of 1,000, it comes out 3. And the reason that's an even number, remember this is base 10. That's because 10 to the third power is 1,000. So these are base 10. Whoa. All right? And then if we do a decimal, oops, 0.0058, then we get a negative. So it's approximately negative 2.24 if I round that off. Okay? So you'll round to whatever it says on your assignment, but they'll have you do a few of these. Sometimes people miss these on the test. That always makes me sad because the calculator, you just type it in. Okay? Negatives will happen with decimals, and that's because negative powers make decimals if you think about your scientific notation. And then these are powers of 10. All right, so how does that help us? Well, anytime I see a problem like this, I am recording, guys. I will send you out if I have to keep dealing with this. Do math in the office on your own.
Sorry.
I don't particularly think it's funny. But, all right, so if I see a power of 10, and I'm trying to find a power of 10, this means there's a shortcut. All I have to do is take log of 53. Okay? Because that would be the opposite of a power of 10. And we end up with x being approximately equal to 1.72. You could try that. If you do 10 to the 1.72, it'll be close to 53, not quite, because we did round it off. All right? Now, if I'm going backwards and I have a log with no base here, I know that that's base 10. That's the same thing as log base 10 of x. What is happening to the speaker?
You're popping it.
I'm not trying to.
Well,
all right, so then this, you just do a power of 10. 10 to the 2.55. And by the way, there's a button for powers of 10 above the log key. I don't know why that's important, because typing in 10 wouldn't be a big deal. You can't turn the speaker all the way off, sorry. So if you use that, you get a power of 10, put in 2.55, and we get 354.81, give or take.
Yeah, the sound of your voice is completely drowned out.
It's because the mic flipped upside down. I'm sorry, the clip is broken.
We should turn it
so
off then.
Just part of it, I can hear it coming through the speaker from all the way up here. Part of it's you're too close to the speaker because it's acoustically set to do a whole room. Okay, so I'm recording, so we're going to move on. Natural logarithms. Okay, logarithm with base e. Remember we talked about number e the other day? It's called a natural logarithm. It's because it's used with a lot of natural sciences, biology type stuff. Okay, it's denoted by log little base e, or there's actually a special way to do this, and it's ln. It's called natural log. It's ln because in Latin, natural log is actually logarithm naturale something. I don't know. I'm not good with Latin. And this is also a button on your calculator. If you look, it's right below the log button right here, ln. Okay? So those are the buttons that we will use for these. So if I want to do natural log of 2.78, I just use that button. So I push the natural log key. It puts in ln 2.78. And I can round that off. It's about 1.02. So that's also just a button that is on your calculator that you can type in. Because E's are used a lot as well. All right, so shortcuts from that. If I see natural log of x equals 5,
And then 5 equals.
you just do e to the 5th power. Okay, because the e and the natural log are inverses. So you'll do e to the 5th power, and it comes out 148.41, blah, blah, blah. So I'm just using 2 decimal points. I think on the worksheet it may ask for 3. If I have e to the x power, you just go ln of 5. So ln, oops, I hit the wrong button. Ln of 5, and we get about 1.61. Okay, so these are giving us some shortcuts to rearrange some simple equations. Okay, the next part's just going to let you know that all of the log properties also work for natural logs. Even though it doesn't say log log, they work. So if I have ln of u times v, when we break them apart to expand, it'd be ln of u plus ln of v. And if you like to put the parentheses on those, you can. That's optional. If I have division, it changes to minus. And then the power, you can still bring down and do n times natural log of u. So all of those properties that we saw in the last lesson work for natural logs just like they do other logs with other bases. Okay? Yeah, I don't know what that says. In Lanu. All right, so you guys have that? Everybody good? Not quite? Almost. Let's take a moment to write it down. All right, so if you're asked to, it says rewrite this as a single logarithm. That's just another way to say condense. So if I want to condense this, it doesn't give a base because the base is e. You just have natural log. And then there's going to be a fraction. Which parts go in the top of the fraction? 3x. The 3x and the 5? So what's 5 times 3x? 15x. And then the bottom, I have this 4 that I want to bring over here. So we'd have y to the 4th. So it works just like what we were doing in the last lesson, except it says ln instead of log. So just emphasizing, it's the same thing. They're just using a special base. All right, so then what do we do about all of the other bases, like base 2, base 3, base 700? So we talked about base 10. We only have buttons on the calculator for base 10 and base e. So that's where the change of base theorem comes in.
No.
It's not that bad. The change of base theorem says we can change any logarithm of any base into either common logs or natural logs so that you can do it with your calculator. So if I have log base a of x, I would do log of x divided by log of a, and I could just do that on my calculator, or I can do natural log of x over natural log of a. And what that does is it changes any base into either common logs or natural logs, which are the only 2 buttons they bothered to put on your calculator.
Natural logs are
okay? So if you can use either one, it doesn't matter. Okay? Either one doesn't matter. Shh. Okay? So we're going to try this using both buttons on the next example. So I have log base 5 of 23. So I can either do log of 23 over log of 5 using the log key, or I can do natural log of 23 over natural log of 5. So I'm going to show you that they come out the same.
Exactly the same.
They are, and it's just letting you know you can use either. So log of 23 divided by log of 5 gives me basically 1.95. I do ln of 23 divided by ln of 5. I get the same thing. So they're both about 1.95. Shh. All right, so you get to choose. So on the next one, I have log base 3 of 149. I'm going to use the regular common log, log 149 over log 3.
2.9.
And we're going to use this to do some story problems tomorrow, so it'll get more interesting. So we come out about 4.55.
What the?
And then just for fun, I'll change this one to a natural log. So natural log of 300 over natural log of 7. It's just a choice. It's just a choice.
It's slowly getting to you. Clearly, there's something.
Shh. And that comes out about 2.93. So all of this is just calculator work. We're preparing you for the next lesson where we solve equations and actually rearrange things to do some story problems. Yeah, we're doing it tomorrow.
Oh, fine.